Hello students, welcome to this lecture 1 Introduction to Trigonometry. So in this lecture we will study trigonometric identities and then we will see some examples. So let's get started. So you may recall that an equation is called identity when it is true for all values of variable involved. Okay, like a plus b whole square, this is equal to a square plus 2ab plus b square. So this is one of the identity that we have used in algebra. Okay, so this is algebraic identity. Since this is true for all values of variables a, b. Okay, and likely a minus b whole square, that is equal to a square minus 2ab plus b square, also a algebraic identity. Okay, so if you may recall that an equation called an identity when it is true for all the values of the variable involved. Okay, similarly an equation involving trigonometric ratios of an angle is called trigonometric identity. That means when we have an equation which is involving trigonometric ratios like sin a, sin, cos, sec, tan, cot, cosec. Okay. When this is involved to an equation, then that equation is called a trigonometric identity. So if it is true for all values of angle involved, so in this section basically we will prove one trigonometric identity and use it further to prove other useful trigonometric identities. Okay, so there are some trigonometric identities that we have used in our many problems, for solving problems. Okay, so they are very important identities for our trigonometry chapter. Okay, so let's get started. So in triangle ABC, here right angle at P, so this angle is 90 degrees. So we have here by Pythagoras theorem AB square plus BC square, this is equal to AC square. Okay, so thanks to Pythagoras to give us like this beautiful theorem. Okay, so we have AB square plus BC square, this is equal to AC square. So now dividing each term of 1, here this is question number 1, and if we divide here each term by a square, then here basically we get AB square divided by AC square plus BC square plus BC square by AC square. This is equal to AC square divided by AC square. Okay, so basically here we dividing each term in equation 1 by AC square, and we get AB square divided by AC square plus BC square by AC square, this is equal to AC square by AC square. Okay, and it implies AB by AC whole square plus BC by AC whole square, this is equal to this is AC square. Okay, so BC by AC whole square, this is equal to AC by AC whole square. Okay, and now here we know cos A, that is actually equal to actual side of adjacent side of cos A, this is equal to side of opposite to angle here, angle C. Okay, so side of, according to this angle here, this side is adjacent to angle A. Okay, that is AB, and side of opposite to angle A, this is BC. Okay, so we know cos A, this is equal to AB by BC. So here for this term AB by AC whole square, here this is actually cos square A. Okay, and here for sin A, we know sin A is equal to side of adjacent side of opposite to angle A. Okay, and divided by hypotenuse, and cos A is side of adjacent to angle A divided by hypotenuse. Okay, so AB by AC square, is equal to cos square A, and BC by AC square, this is equal to sin square A. Okay, and AC by AC square, this is equal to 1. Okay, so that is cos A whole square plus sin A whole square, this is equal to 1. And we know cos A whole square, this is actually cos square A, and sin A whole square, this is equal to sin square A. Okay, so cos A whole square plus sin A whole square, this is equal to 1, and that is cos square A plus sin square A, this is equal to 1. Okay, and naming this equation number 2, and this equation number 2 is true for one value of A such that 0 degree less than equal to A less than equal to 90 degree. So this is a trigonometric identity. Okay, so cos square A plus sin square A, this is equal to 1. This equation is a trigonometric identity, since this equation is true for all values of A where where 0 degree less than equal to A less than equal to 90 degree. Okay, so now let us now divide equation number 1 by AB square. So now if we divide equation number 1 by AB square, then what will happen? So then we get AB square by AB square plus BC square by AB square, this is equal to AC square by AB square. Okay, and for AB by AB whole square plus BC by AB whole square, this is equal to AC by AB whole square. Okay, this is equal to AC by AB whole square, and here AB by AB whole square, this is equal to 1, and BC by AB, that is actually equal to side of adjacent to angle A divided by side of opposite to angle A. This is actually tan A. Okay, so BC by AB, this is tan A. So BC by AB whole square, this is equal to tan square A, and here AC by AB, this is equal to sec square A. Why? Because we know sec A is equal to 1 by cos A, and cos A is basically side of adjacent to angle A divided by hypotenuse. Okay, so sec square A is equal to hypotenuse divided by side of adjacent to angle A. So AC by AB whole square, this is equal to sec square A. That is 1 plus tan square A, this is equal to sec square A. Okay, and is this equation true for A is equal to 0 degree? So if we substitute the value of A is equal to 0, then here you will get in left hand side 1 plus tan square 0 degree. This is equal to 1 plus 0 is equal to 1. Okay, so in left hand side we get 1, and now if we substitute the value of theta is equal to 0 degree in right hand side, then you will get sec square 0 degree, this is equal to 1 by cos square 0 degree, and we know cos 0 degree is equal to 1. Okay, so sec square 0 degree is equal to 1. So here left hand side and right hand side are equal for A is equal to 0 degree. Okay, so yes, this equation true for A is equal to 0 degree. And now what about A is equal to 90 degree? So well, if we now substitute value of A is equal to 90 degree in this equation, then in left hand side we get 1 plus tan square 90 degree, that is equal to 1 plus 1 that is equal to, will get some values. Okay, and in right hand side you will get some values, and here you will get left hand side is equal to right hand side. Okay, so this equation is true for A is equal to 90 degree. Okay, so well, tan A and sec A are not defined for A is equal to 90 degree, so root 3 is equation 3 is true for all A such that 0 degree less than equal to A less than equal to 90 degree. Okay, so let us see what we get when dividing 1 by BC square. Okay, so then we get AB square by BC square plus BC square by BC square, this is equal to AC square by BC square. Okay, that is AB by BC whole square plus BC by BC whole square, this is equal to AC by BC whole square. Okay, and here AB by BC, this is actually equal to cot A. Why? Because cot A is equal to 1 by tan A, and we know tan A is equal to side of adjacent to angle A divided side of opposite to angle A divided by side of adjacent to angle A. Okay, so here AB is side of adjacent to angle A, and BC is side of opposite to angle A. So here AB by BC, this is equal to cot A. So AB by BC whole square, this is equal to cot square A obviously, and BC by BC whole square, this is equal to 1, and AC by BC whole square, this is equal to cosec square A. So we get this equation cot square A plus 1, and this is equal to cosec square A, and naming this equation number 4. So this equation is also a trigonometric identity. Okay, so note it down. Cosec A and cot A are not defined for A is equal to 0 degree. So therefore equation 4 is true for val A such that 0 degree strictly less than A less than equal to 90 degree. Okay, so here for this identity 1 plus tan square A is equal to sec square A. Here this identity is true for val A such that 0 degree less than equal to A strictly less than 90 degree. Okay, and this identity cot square A plus 1 is equal to cosec square A. This identity is true for val A such that 0 strictly less than A less than equal to 90 degree. Okay, so using these identities we can express each trigonometric ratio in terms of other trigonometric ratios. So that is, if any of the ratios is given, then we can also determine the values of other trigonometric ratios. Okay, so this is the benefit. This is the benefits of this identity. Okay, using this identity we can express each trigonometric ratio in terms of the other trigonometric ratios. So basically here we get three identity. One identity is cos square A plus sin square is equal to 1, and second identity is 1 plus tan square A is equal to sec square A, and third identity is 1 plus cot square A is equal to cosec square A. Okay, so now let us see how we can do this using these identities. Okay, so how can we find other trigonometric ratios by using this identity if we have given one trigonometric ratio? Okay, so let us see how we can do this by using this identity. So suppose we know that tan of A is equal to 1 by root 3. Okay, so suppose we have given the value of tan A is equal to 1 by root 3, and then we can easily find cot A, that is actually reciprocal of the tan A. So cot A is equal to root 3. Okay, and now since we have this identity sec square A, this is equal to 1 plus tan square A, and here the value of tan A is equal to 1 by root 3. So now here if we put the value of tan A is equal to 1 by root 3, then we get sec square A is equal to 1 plus 1 by root 3 whole square, that is equal to 1 plus 1 by 3, and this is equal to 4 by 3. Okay, so sec square A, this is equal to 4 by 3, so it implies sec A is equal to 2 by root 3. And we know cos A, this is actually reciprocal of the sec A. Okay, so reciprocal of sec A, so here we have sec A is equal to 2 by root 3, so cos A is equal to root 3 by 2. Okay, and we have this identity sin square A plus cos square A is equal to 1. So from this identity we easily find the sin of A. So sin of A, this is equal to square root of 1 minus cos square A, and here we get the value of cos A is equal to root 3 by 2. Okay, so now if we put the value of cos A is equal to root 3 by 2 in this equation, sin A is equal to square root of 1 minus cos square A, then we'll get this is equal to square root of 1 minus 3 by 4. Okay, and this is equal to square root of 1 by 4, this is equal to 1 by 2. Okay, so therefore cos A is equal to 2, since cos A is equal to reciprocal of the sin A. So here we find the value of sin A is equal to 1 by 2. So therefore cos A, this is equal to 1 by sin A, that is equal to 2. Okay, so initially we have given the value of one trigonometric ratio, that is we have given tan of A is equal to 1 by root 3. Then we find the value of cot A, that is actually reciprocal of the tan A. So cot A is equal to root 3, and by using this identity we find the value of sec A, that is equal to 2 by root 3, and we use the definition of cos A is equal to 1 by sec A, that is then we get cos A is equal to root 3 by 2, and by using this identity sin square a plus cos square is equal to 1, here we get the value of sin a in terms sin a in terms of cos a is equal to square root of 1 minus cos square a. And here after substituting the value of cos a is equal to root 3 by 2, here we get the value of sin a is equal to 1 by 2. And then we know cosec a this is equal to 1 by sin a, and therefore cosec a is equal to 2. Okay, so by using these identities, you can find other trigonometric ratios by trigonometric ratios if we have given the value of one trigonometric ratio. Okay, so now let us see some examples. So here in this portion, here we'll explore some examples. So let us see this example. Here in this example, here we have to express the ratios cos a, tan a, and sec a in terms of sin a. Okay, so we have to express cos a, tan a, and sec a in terms of sin a. So let us express. So here, since we have this identity cos square a plus sin square is equal to 1. Okay, so therefore from this identity here we get cos square a is equal to 1 minus sin square a. That is cos a, this is equal to plus minus square root of 1 minus sin square a. Okay, so cos a this is equal to plus minus square root of 1 minus sin square a, and this gives cos a this is equal to square root of 1 minus sin square a. Okay, and so cos a is equal to square root of 1 minus sin square a, and hence tan a this is equal to sin a by cos a, and this is equal to sin a by square root of 1 minus sin square a. So here we put the value of cos a, this is equal to square root of 1 minus sin square a, so this is equal to sin a by square root of 1 minus sin square a. And then sec a this is equal to 1 by cos a, and this is equal to 1 by square root of 1 minus sin square a. Okay, so cos sec a is equal to 1 by square root of 1 minus sin square a. And then and so here we express the ratios a cos a in terms of sin a as cos a is equal to square root of 1 minus sin square a, and we express the ratio tan a in terms of sin a as cos sin a by cos a, this is equal to sin a by square root of 1 minus sin square a. And here we have expressed the ratio sec a in terms of sin a as sec a is equal to 1 by cos a, this is equal to 1 by square root of 1 minus sin square a. Okay, so now let us see next example. So in next example, here we have to prove that sec a into 1 minus sin a into sec a plus tan a, this is equal to 1. Okay, so here we have to prove this. So now let us see how to prove it. Okay, so here in left hand side we have sec a times 1 minus sin a into sec a plus tan a. This is equal to, here sec a is reciprocal of the cos a, so sec a is equal to 1 by cos a, and here 1 minus sin a, and we know sec a is equal to 1 by cos a, and tan a is equal to sin a by cos a. So if we put sec a is equal to 1 by cos a and tan a is equal to sin a by cos a, then we'll get this is equal to 1 by cos a times 1 minus sin a times 1 by cos a plus sin a divided by cos a. Okay, and now if we simplify it, then we'll get this is equal to 1 minus sin a into 1 plus sin a divided by cos square a. Okay, and we know this identity a plus b times a minus b, this is equal to a square minus b square. Okay, so now if we use this identity, then we will get 1 minus sin a into 1 plus sin a as 1 minus sin square a. Okay, so 1 minus sin a into 1 plus sin a, this is equal to 1 minus sin square a, and cos square is as it is. Okay, so this is equal to 1 minus sin square a divided by cos square a. And we know this identity that we have seen in our previous slide. So we know this identity sin square a plus cos square a, this is equal to 1. Okay, so from this identity here 1 minus sin square a, that is equal to cos square a. So 1 minus sin square a divided by cos square a, this is equal to cos square a divided by cos square a. So in numerator and denominator they are same, so this is actually equal to 1. Okay, so and this is our right hand side. So here left hand side, this is equal to right hand side. So therefore sec a into 1 minus sin a into sec a plus tan a, this is equal to 1. Okay, so now let us see next example. So in next example, here we have to prove that cot a minus cos a divided by cot a plus cos a, this is equal to cosec a minus 1 divided by cosec a plus 1. Okay, so here in left hand, basically we have to simplify left hand side and right hand side. Okay, so here in left hand side we have cot a minus cos a divided by cot a plus cos a, and we know cot a is equal to cos a by sin a. Okay, so here we can write this is equal to cos a by sin a minus cos a, and divided by cos a by sin a plus cos a. Okay, and this is equal to cos a times 1 by sin a minus 1. Basically here we common out cos a from numerator. Okay, so cos a times 1 by sin a minus 1, and we've also common out cos a in from denominator, then we get this is equal to cos a times 1 by sin a plus 1. Okay, so here this term will cancel, and this is equal to 1 by sin a minus 1 divided by 1 by sin a plus 1. Okay, and we know 1 by sin a is basically cosec a, so this is equal to cosec a minus 1 divided by cosec a plus 1, and this is our right hand side. So here left hand side, this is equal to right hand side. Okay, so therefore cot a minus cos a divided by cot a plus cos a, this is equal to cosec a minus 1 divided by cosec a plus 1. Okay, so proved. Now let us see next example. So in next example, here we have to prove that sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1, this is equal to 1 by sec theta minus tan theta. So here we have given this hint. Here we have to use the identity sec square theta is equal to 1 plus tan square theta. Okay, so let us see how to prove it. So here, since we will apply the identity involving sec theta and tan theta, here let us first convert the left hand side of the identity we need to prove in terms of sec theta and tan theta by dividing numerator and denominator by cos theta. Okay, so in left hand side we have this sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1. So here we have to write this side in terms of this part in terms of tan and sec theta. Okay, so tan theta and sec theta. So here basically we dividing numerator and denominator by cos theta. So this is equal to tan theta minus 1 plus sec theta divided by tan theta plus 1 minus sec theta. Okay, and this is equal to tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1. So basically we rearrange this and we get this. Okay, and this is equal to tan theta plus sec theta minus of tan theta minus sec theta, and divided by tan theta minus sec theta plus 1 of tan theta minus sec theta. Okay, so here this is equal to tan square theta minus sec square theta minus of so here is equal to tan square theta minus sec square theta minus tan theta minus sec theta divided by tan theta minus sec theta plus 1 of tan theta minus sec theta. Okay, and here this is equal to minus 1 minus tan theta plus sec theta divided by tan theta minus sec theta plus 1 times tan theta minus sec theta. Okay, and this is equal to minus 1 by tan theta minus sec theta, and this is equal to 1 by sec theta minus tan theta, and this is our right hand side. Okay, so which is the right hand side of the identity. So here left hand side is equal to right hand side. Okay, so right hand side, left hand side is equal to right hand side. So hence this is true. Okay, so sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1, this is equal to 1 by sec theta minus tan theta, hence proved. Okay, so I stop here this lecture. Thank you very much to all of you.